Hey guys, it's Mr. Morrissey. Today we are solving simple rational equations or inequalities in one variable, and we're going to show how you can see the idea of extraneous solutions. So you can read the notes here, pause it, read the notes. You should also have printed out the notes from the Google page. Alright, let's look at number one. We're going to get a common denominator. And the common denominator is x minus 3 and x multiplied together. So let's see. 2 over x minus 3 has an x minus 3, but it does not have an x. 1 over x, the numerator 1, has an x, but doesn't have an x minus 3. This x minus 1 is divided by x minus 3, but it doesn't have an x. Hey, why did he do that? Why did I put those things x and x minus 3 or then x minus 3 times x? No reason for that. Just I don't know why my brain did that, but it doesn't matter. You notice, if I was to say, okay, is 2x divided by x times x minus 3 the same thing as 2 over x minus 3? You might remember from class I'll like cover up this part and I'll say, well, look, 2x divided by x times x minus 3, the x's would cancel and you'd go back to 2 divided by x minus 3. And 1 times x minus 3 divided by x times x minus 3, the x minus 3's would cancel and you'd go back to 1 over x. So let's see. Here we can multiply both sides by x times x minus 3. I put in the invisible 1x. Now the denominators are gone, which is great. Now we just have a quadratic. So now we're just going to solve. Occasionally in class, or a lot actually, I say solve for 0. So let's see, move all this stuff over to the other side. Well, first I'm going to simplify this. And then move everything over. Now we're going to factor. So this is from the quadratics unit. Three is a prime number, so it's has to be 1 and 3 if it does actually factor. So x is 1, x is 3. Hold up, we can't have 3. This is the idea of extraneous solutions. Okay, so that's a no. Okay, so 3 doesn't work because you should see immediately that if you plug in 3 right there, you're dividing by 0. So x equals 1 is the only answer. Sometimes I even write x equals 1 only, but you don't have to do that. So this is the idea of the extraneous solution, that 3 cannot be the solution. Okay. That's a good problem. It's not too hard. It's not too easy. It uses the idea of extraneous solutions. You have to find the common denominator. You have to factor. It's a good problem. Remember, you can always pause. All right. Let's see. This one, there will be an extraneous solution, but you're going to see at the end that I really think, unless I allow you to use a calculator, I think it's a little unreasonable to think you might plug in one of the solutions to check to see if it has an extraneous solution. But let's get to that when we'll cross that bridge when we get to it. So here we go. Here, common denominator is x minus 3, x plus 3. We're going to notice that x squared minus 9 is a difference of squares. Classic SAT difference of squares. X squared minus 1, x squared minus 4, x squared minus 9. Those are the key SAT difference of squares. Key. And we've already done this, guys. We've done this in our quadratics unit. So that should be a review. Okay, let's see. Let's just start by multiplying both sides by x minus 3 times x plus 3. Well, this term here lacks an x plus 3. This term, 8x squared, lacks nothing. It has an x squared, it has an x plus 3 and an x minus 3. And this term here lacks an x minus 3. Okay, so we're going to expand and then condense. You guys are being so quiet. So here, 4x squared plus 12x equals 6x plus 18. Now, how about we move everything to one side? So we're going to solve for 0. Not sure if that's like a typical math term, but that's what I say. So when I subtract the 6x, I get that. All right. If we were in class, I would say, you know, what do we see next? What can we do to what's our next step? Not trying to lead you. You want to divide by 2. You want to see 4, 6, and 8 all are even numbers. You can divide by 2 to make your life easier. Simplify your life. That's good advice. So simplify your life. Make the equation much easier to solve. Okay, it'll really help you. Now we want to factor. Okay, here we go. So 9 could be 1 and 9 or 3 and 3, but I know it's 3 and 3. We need to have negative 9, so 1 has to be negative, 1 has to be positive, and we need positive 3. So let's put in negative, negative. There we go. Negative 3 times positive 3 is negative 9, guys. And, excuse me, 3 times 2 is 6. 6 minus 3 is positive 3. So we're thinking the answers are 3.5. Oh, no, not 3.5. 3 halves. And x is negative 3. Again, you should see immediately. This is extraneous. Write this one more clearly this time. Extraneous. Now, at the beginning of this problem, I said, well, you know, it's a little bit tough to see that 3 over 2 would you know, it's tough to, if you take 3 over 2, you'd have to plug in here, 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 and there. That's really a pain without a calculator. So if you had a calculator, you could do it. If not, in our class, you're going to assume that 3 over 2 is an answer. Okay? But you definitely need to know that negative 3 wouldn't work. That you can just see by visually looking at the problem. All right, guys? We'll do one more, and then we'll take a break. Okay, oh gosh, an inequality. This is we did this in our polynomials unit. So we have solve 6 over x minus 2 is greater than or equal to negative 4. First thing, solve for 0 every time. Notice I'm writing 4 as 4 over 1. Okay, we solve for 0. Now we want to get common denominator. So we do a little simplifying, guys. Okay. Okay. We have 4x minus 2 divided by x minus 2. God, I know everyone sees this, but I'm just going to point this out real quick. I know people are not going to be like, wow, look at that, x minus 2 over x minus 2. Let me cancel that real quick and get 4. And 4 is greater than 0. You might think, oh, it's all real, all real number solutions, or all, infinite solutions. But I know that's definitely. I just wanted to point that out there. So look, let's do a graph. Okay. So this goes back to our first lesson on rational functions. You're going to see 2 is a ... vertical asymptote. Then you look at for the horizontal asymptote. So horizontal asymptote, you take here, this is x to the first divided by x to the first. So those would cancel. Like if you have 4x over 1x, if you were to plug in infinity, that's going to be 4. So there's going to be a ... horizontal asymptote at y equals 4. This was x equals 2. Let's see. Let's find the y-intercepts real quick. So the y-intercept, plug in 0 for x. Oh, wait a minute. I'm not plugging in the right way. Sorry. Let's plug it in here. So this is going to be -2 over -2. That's 1. So the y-intercept is 1. And then the x-intercept is when the numerator part equals 0. So, I meant to say x-intercept. We can see that's going to be a half when you solve this equation. So, we could test some points, but I'm quite confident the graph looks something like that. So we look at this and we're like, okay, real quick, where is this graph greater than or equal to 0? Okay, so greater than or equal to 0, well, all points over here greater than 2, so we're going to put my answer. So, pull a box. So, answer. X can be greater than 2, all these points over here, but you can't have it include 2, because that would be an undefined region. And then, at this x-intercept, you're equal to 0, and then all of these points going this way are going to be greater than 0. So we're going to also have x is less than or equal to, this time, a half. Okay. So in this problem, we solve for 0. We use some old skills to try to find the horizontal and vertical asymptotes. Here, x minus 2 gives you the vertical asymptote at x equals 2. And then the ratio of the leading terms, 4x divided by x, gives you 4. That's a horizontal asymptote at y equals 4. And then we found the x and y intercepts. And we know the general shape of the curve, a rational curve, usually looks the same, especially if there's only 2 regions. If you weren't confident on this, you could test a few more points. But I think you're going to be confident going forward. And that's about it. So the answer is x is greater than 2 and x is less than or equal to a half. Hope you're having a great day. Bye, guys.